we talk about the quadratic equation and the linear equation, how many intersections they can have. So if you can think about the shape of the graph, we will have three different cases. So the first one is they just cross at 2 points. Well, anywhere, just cross twice. Second situation will be they're not touching each other at all. Okay, one going up, one going down, they're not going to touch each other at all. And the third case is a little bit special. It's called the tangent of the graph. So we'll learn tangent like for the fourth or the third term. So the tangent means it's only touching exactly 1 point. Okay, it's just like a touching. It's just a touching point. So that will be the three different cases we will have for a linear and a quadratic by graph it. If we can think about the equation, so there's a k value. The k value will be like changing the graph like a little bit, like the turning point and also up or down. So you will meet the line 3x minus 4. If you change the k value, like different cases will happen. So let's think about if we want two intersection, one intersection, and no intersection separately. So this is a simultaneous equation. First of all, we want to set up the equation, like put them together. So y should equals to y. So we have x squared minus kx equals to 3x minus 4. Okay, that's what I will do first. And then because we can see that's a quadratic equation, I want to solve for zeros. I want to make everything to one side first. So how do we solve quadratic? We make one side equals to 0 and factorize and so forth. So we follow the same step. So minus kx minus 3x plus 4 equals to 0. So we can see the middle two sections, they all got x. Okay, they all got x. So x squared, we can say minus k plus 3x plus 4 equals to 0. So we combine the k and 3 to make it to become the coefficient of the x. Therefore, we can see the a value is 1 in this case. The b value is minus bracket k plus 3. And the c value will be 4. Remember to include the negative sign as well, because that's part of the value of b. So we need to take the sign into consideration. So now let's have a think. I don't know the k value, but if I can solve for it, I can use the quadratic equation. I just write the quadratic equation out for you. So x equals to minus b plus minus square root b squared. So b is that, and I need to square it. B squared minus 4 times 1 times c, 4ac over 2a. That's how we solve for it, by using quadratic equation. But whether we can solve it or not is totally depend on the thing in the square root, because we can't have negative number in the square root. If the k, let's say, is too small, and then I don't have, like, the back is a minus 16, so if that's too small, I just have a negative number, so it can't work, so it won't have any solution out. Therefore, I will say my discriminant is minus k plus 3 squared minus 4 times 1 times 4. So this is something to test how many solutions we will have. That's equals to, okay, this will become a k plus 3 squared minus 4 squared. Because the minus square will just become positive. So what we left is k plus 3 squared. And I can factorize that. Well, you know why I'm going to factorize it later. So you can expand. Okay, here you can expand, but like I see I can factorize it. I think it's always helpful if I can factorize a quadratic, because when we're sketching, we factorize it. When we solve, we factorize that. So we all need the factorized form actually. So I will factorize by using the a plus b and a minus b formula. So a squared minus b squared equals to a plus b and a minus b. What we have is a k plus 7 and k minus 1. That's the result I will have. Well, that's my discriminant. That's my discriminant. So if you want two intersection, one intersection and no intersection, so there will be three different cases. I will go for the one intersection, like one intersection case. So if you want one intersection, which means I want a single x, like I just can solve out one single x. Because of the plus minus there, you will have two solutions unless you have the discriminant is 0. So if that's a 0, plus a 0 or minus a 0, that will be the same thing. Okay, anything plus 0, anything minus 0, you only have one solution, which is the k plus 3 over 2. So I will make discriminant equals to 0. So for one solution, discriminant will be 0. So if you have that equals to 0, what you can solve out is equals to minus 7 or 1. K equals to minus 7 or 1. What's the question? What's the question? Any question? No? So that's the one intersection case. Now if you think about no intersection, if a no intersection, so we need a negative number under the square root, and which the system fails and you can't work what is the x value. So there I need the discriminant less than 0. I need the discriminant less than 0. So k plus 7 and k minus 1 less than 0. This is the quadratic inequality. Okay, this is the quadratic inequality. So we need to sketch the graph. Okay, negatives, I just need the x-intercept. I need negative 7 and 1. Because it's a positive quadratic, it will look like this. Okay, it will look like this. I want, as I said yesterday, you can make that left-hand side say y equals to that. Then that's this graph. So you need a y value less than 0. Need a y value less than 0, which will be this part of the graph. That's the y value less than 0. So open circle here, you can't take 0. So you take 0 and in the first step. So you don't have 0 for those 2 points. And the corresponding x, if you draw vertical lines up, so you can see where is your x. So you're touching the x here. Okay, so in between the 2 points. So the answer will be negative 7 less than x less than 1. So that will be your k, sorry, not x, k. That's the k-axis. So your k value needs to be in between negative 7 to negative 1 to make that whole equation less than 0. So those k values will give you the y value less than 0. Therefore, discriminant is 0. Yes? No intersection means it must be less than 0. Equals to 0 is the first case, which you only got one intersection. Equals to 0, you still can intersect. It's like the touching case. Because you intersect, that square root 0 is 0, right? Square root 0 is 0. So k plus 3 plus 0 and minus 0 will be the same thing. So you still have one solution. That's why I don't take the 0 here. This case, I need it less than 0. Absolutely less than, not equals to 0. Yes? Yeah? Olivia?
If on a test I wrote like k is larger than negative 7 and then separately k is less than 1, would be marked down?
It won't be marked down, but like they actually should be right in this way. It's just a notation thing. But if you say, wait, do you use the and or in between that? That will make a difference. If you say negative 7 less than k, no. Like it depends. If I think a comma means or, it's not an and. Like it means it needs to be an and, less than an and, greater than that. So the intersection in between. But if you say that or that, then it's a larger set. It's not like actually in between here. Yeah. That's the second case. And for the third one, I want two intersections. So two intersections, we need discriminant absolutely greater than 0. So if we need greater than 0, we can see like, I'll draw it in green. greater than 0 will be this part, and this part of the graph is whatever left. Okay, whatever left. So it's left hand side of -7 and right hand side of 1. They all will be the correct answer. So you will say k less than -7 and k greater than 1. K less than -7 and k greater than 1. So both parts we can take. Okay, we can take both parts. Those green graph will give you a y value greater than 0, and then you can see the k value on the x-axis that will be less than -7 and greater than 1. So this is a good question. It put the discriminant question and quadratic inequality together to ask you to solve for 3 different cases. So this will be an important question. I have seen this in VC exam as well. Okay, so even though it's year 11, this still can appear in VC exam. So it's a quite important question. Any questions for that one? Okay, if we don't have any questions here, let's go to the next page. Next page. Okay, so it's like this is called the family of quadratic polynomial functions. So do you remember we learned the linear family functions, like the family of linear functions, like every very beginning lesson? We say there are 2 different cases that can be family of linears. One is they all parallel to each other, and the other one is they all pass through the same point. When we pass through the same point, we can say they pass through y-intercept, x-intercept, or any other points. So for quadratic graph, like there's more, like a lot of things they can share in common. So for example, well, we don't really have gradient, but we can say they all have the same width. Okay, they all have the same width, that's one. Or we can say they all have the same y-intercept, or they all have the same turning point, or they all have the same x-intercept. Like they have one same x-intercept, they have 2 same x-intercept, they have one same x-intercept and the turning point. There are so many combinations we can talk about for quadratic. So we don't really pay that much attention into this. So I'm not really even put the table there for you to say what's in common. It's not necessary. But like think back, like what is the important thing for quadratic, and we keep using it to year 12, is the 3 form of quadratic. Okay, so the first form is called the general form, which is ax squared plus bx plus c. The second one is the turning point form. When I marked the paper you did like on Tuesday, so there's a question giving you the turning point and ask you to expand it to the quadratic way. Okay, a lot of you just not get that right because you can't think about whether it's minus h or plus k or minus k, like you don't really get it. So you remember that question wrong. I think 3 or 4 you make x minus h squared minus k. Okay, that's your answer. So that is the formula, like you can't remember the formula. So the formula is minus the x coordinates but plus the y coordinates for the turning point. That's the turning point formula, which is the most important thing for the quadratic equation. And the third one is the x-intercept form. X-intercept form is y equals to a bracket x minus the first intercept, finish the bracket, and another bracket x minus the second intercept, which is the factorized form. But doesn't matter whether you use the turning point form or the x-intercept form, there is an a in front of all the equations, and you must remember that. So I see, which is really good. Like for this class, I think there may be 1 or 2 like missing that a. So directly substitute the turning point in and just not writing the a. Most of you know there should be a dilation here, and you need another point to find the dilation, which I'm really happy about that fact. So just don't forget you need a in front of that. When you know the turning point, you can't define the function yet, because if you see that's a turning point at 0, 0, and I can draw another graph like this, it still have the same turning point at 0, 0. You don't know the dilation here, so you need another point to help you. So that's one thing. X-intercept form, same thing. If I can draw a thinner graph here, that is the same, share the same 2 x-intercepts as well. So you must have that a to find the dilation. All right. let's come to the first one. So if give you a general form, okay, if give you, not given general form, the general form is introduction. Let's see the question. The star is the question. Parabola passes through the point 1405 and -110. These 3 points are 3 random points. You have no information on those 3 points. They are not x-intercepts, they are not turning points, which we can only use the general form to solve for it. But which value you can tell me first? C, yeah? The C value. So C value is 5. So we can directly, by using the y-intercept, to find the C value. Okay, we try to substitute the C value directly. We want to reduce the difficulty of solving that. You don't want to solve A, B, C like 3 linear equations for 3 variables. It's very hard to solve. We want to reduce that to 2 variables first and then solve for it. And then we just do substitution. We sub x equals to 1, y equals to 4 into the equation. We have 4 equals to a plus b plus 5. And for the second one, we have 10 equals to a minus b plus 5. Okay, so we have here a plus b equals to -1. And we have a minus b equals to 5. Okay, do you add or subtract the 2 functions? Well, it doesn't really matter this one. We can add them, So if we add them, we have 2a equals to 4, which a equals to 2. And we have b equals to, well, a is to 2 plus b equals to 1. b equals to -1. b equals to, that's -1, sorry, that's -1. b is -3. So you can check for the next one. A minus b needs to be 5. a minus -3, that is 5. So the equation will be y equals to 2x squared minus 3x plus 5. This is like easy one, so the number is not large. So give you 1 and -1, which only give you a, b, c. The coefficient is all 1. Okay, so that's the general form. We only, okay, in that question, the question in the test, like I see some of you trying to directly, because the question asking for general form, and a lot of you start from the question, if you can still remember what you have done, start from the general form. Okay, that's actually a very hard way to do it, because the number are not like as small as these ones, and it's also including the turning point for you. So there's no point to use the general form. General form is the hardest way of finding the equations. So you can use the turning point form and then expand it and then find the general form. So if you have no choice, then use general form. If you have turning point or 2 x-intercepts, definitely not to use the general form. It saves you a lot of time. Turning point form, y equals to ax minus h plus k, where h and k is the turning point. So there are 2 questions below here. The first one says the coordinates of the turning point of parabola is 2, 6. So the parabola passed through the point 3, 3 as well. But that 3, 3 is not a special point. It's just any point on the graph. So you can write your equation in the way of y equals to ax minus 2 squared minus the x-intercept, but plus the y-intercept. Okay, but plus the y-intercept. And then sub the point 3, 3 in. So 3 equals to a bracket 3 minus 2 squared plus 6. We have 3 equals to a plus 6. A equals to -3. So y equals to -3, x minus 2 squared plus 6. Okay, for the next one, what turning point we have? 0, 0. So what you will write? If the quadratic pass through the origin, what kind of equation you have? Y equals to ax squared. That's right. Y equals to ax squared. Because it passed through the origin 0, 0. So the equation will just be y equals to x squared. It's just called dilation. Okay, that way or that way. So we find another point which is 2, 5. We just sub the 5 in. 5 equals to a times 2 squared. A just be 5 over 4. So y is 5 over 4 x squared. Why is y equals to ax squared? If you know the turning point is 0, 0, I can say that's y equals to ax minus 0 squared plus 0. And that's just y equals to ax squared, if you can simplify that. So that's why we have this equation at the beginning, y equals to ax squared. So when you can see any turning point in the equation, you will in the question you give you any turning point, you will definitely use turning point form to solve for it. Turning point form is the most helpful form for quadratic equation. So if you can see turning point, use turning point. Okay. If you have intercepts and turning point, choose the turning point. Okay, choose the turning point. Okay, for the next one. X intercept form is x minus one intercept times x minus another intercept. That's the factorized form. So a quadratic has x intercept at -3 and 4. It also passes through the point 1, 24. So the x1 and x2 are -3 and 4. What we can write is y equals to x minus, okay, -3. X minus 4. Okay, minus the x intercept. That's ax plus 3 and x minus 4. Then we can sub the point in. So 24 equals to a1 plus 3, 1 minus 4. So 24 equals to a times 4 times -3. So a is -2. -12 and a is -2. So y is -2 x plus 3 and x minus 4. That's the three method how we can find the equation for the quadratic, which are the very basic thing and is very useful thing. So year 12 we still need these skills. Okay, next one. Next one, we can't see turning point here. We don't know where's the turning point, but I can see 2 x intercepts. Okay, one thing, if you want to use x intercept form, there must be 2 x intercepts. Okay, if you don't have 2 x intercepts, you can't really use for it. Like, you can only write one bracket, you don't know what's the other bracket. Then, like, if you write in that form, you need another point to find the other intercepts, which is more complex. It's rather just we can use the general form, which is even easier. So you need 2 x intercepts given to you, and then you use this form. So it's like very limited, like this method is very limited, must got 2 x intercepts. So for that one, you can just have the turning point and any other points. Only need 2 pieces of information. Turning point worth 2 pieces of information, which is really good. So for this one, we have 0 and 3 as the intercept. We can write y equals to ax minus 0 and x minus 3. So we have 8 equals to a minus 1 minus 1 minus 3. So 8, that's minus 1, that's minus 4. So it's a 4a. A equals to 2. So y equals to 2x, x minus 3. So it's a single factor x. Any questions so far? So that's the 3 methods how we find the equation for quadratic. And the bottom part is the thing I'm talking about. So the family of graphs. Just generally talk about this. Like there will be more things you can have in common. There will be more, but I'm not going to list all of them. Like there are so many combinations. I can have same x-intercept, same and same shape. I can have 2 different intercepts at the same, y-intercept the same, or y-intercept same, or 2 x-intercept same. So there are so many combinations, I can't really list all of them. But I'll just keep talk about some key things. So for the first one, I have, or the second one, I write same shape in the bracket. So what's the same shape depends on is the a value. Okay, the a value depends on the shape. Because that's the dilation, that's the stretch. Okay, that's the stretch. So if you stretch the same amount, like 2, so that will give you the same value. So that's the same shape where that comes from. Same y-intercept because they all have a y-intercept at 1 for the second. And for the third one, we know that is the X Intercept Form. So it's just the dilation different. They all got same X intercept. And for the fourth one, I have y-intercept in common. I don't know what's the other b. Like it can be -1 and any other points. So I don't know the other one, but there's one x-intercept in common. Same y-intercept for the second last and same turning point for the last. Like it's very obvious. I put those ones are very obvious ones. So there will be more like tricky ones, but you don't really need to know that. Okay, so that's the family. They are all family of quadratics. So that's for the exercise K. And the last one. Well, last one is really easy, just by substitution and like wording questions. We have learned everything, but this one is just a wording question. So it's called quadratic models. So the bending moment m at each point of a simple beam use the bridge construction is given by that formula. So formula is given m, w, l, x. Okay, it's all given. Where w is the width of the beam, L, this is the L. L, not 1. L is the length of the beam and X is the distance from one end. If L is that, W is that, M is that, calculate the value of X. Basically, solving quadratic equations by substitution. So we sub M equals to 288 equals to W is 16, L is 13, divided by 2 times x minus w 16 over 2 and x squared. Okay, can you see like the number is quite large here, and I don't want to really use that large number to calculate. So I want to know what's in 288. So I can see the last 2 digits is 88, so I can definitely divide that by 4. Okay, if the last 2 digits can be divided by 4, the whole number can be divided by 4. So I will try 4 here. 72. So it's 4 times 8 times 9. So 4 times 8 is 4 times 4. So 4 times 4 times 2 times 9. Why I'm doing that? I have a 16 times 18. Okay, 16 times 18 here. Why I need a 16? Because I can see 16 in all the numbers. So I will divide the 16 on both sides of the graph. Okay, 16 on both sides of the graph equation. So I have 18 here. That's 13 over 2. X minus divide the 16, I have half. x squared. Well, I can times by 2, 36, 13x minus x squared. I can put everything to one side. Equals to 0. 1 minus 4 minus 9 should give me a minus 13. So I can factorize that as x minus 4 and x minus 9. So x is 4 or x is 9. Okay, so x is 4 and x is 9. So that's just by substitution. If you understand the question, just substitute the value in and then solve for the quadratic, which is a really easy exercise. There will be some harder questions in the textbook of that exercise, so more wordy questions, but you can try for those ones. Do you have any questions so far for this lesson? Okay, if it's not, there's no questions, we have finished the whole chapter 1 to 3. Tomorrow lesson and the rest of this lesson will be like you catch up your homework or any revisions you need to do. So will be a revision lessons. If you have any question, I'm here to help. And your test will be the 4th week after the swimming. I put the date on the schedule for you so you can have a look in the Google Classroom. So that will be our test days. Questions?
So from now till the test?
No. It's only next lesson and today the rest of the lesson. We move on to chapter 4 and 5.
Okay.
Yes?
What's the topic 1?
1 to 3 topic. Chapter 1 to 3. That's what we learned so far.
So like our revision test?
Revision tests only cover the homework, but we have add some new things into this chapter.
So is the test start with the new stuff as well?
And the old one as well. You can't separately test you about the new things. It will be a combination. Yes?
So it's basically everything.
Yeah, everything in the booklet. Right.
What about matrices?
No. That's not really belongs to this booklet. The matrices will be learned later. Okay, that's it.
I don't know how to do it.